writing notes. Remember, these packets are summaries and practice AP problems for the topics that are covered in much more detail in your notes. All right, cool kids, let's go ahead and peek at. Okay. Start with number 3. Once again, if you're like, I'm bored, cool, you're doing ons in the next packet. And if you're like, I'm not bored, sweet, let's learn. And write little notes to yourselves. And have your graphing calculators open, etc. Number 3 is a graphing calculator problem, and I actually had this one on a graphing calculator from period 6 yesterday. So let's go ahead and peek at it. What I've done so far is I have graphed, I've graphed 2x sine of x. Oh, it's up there. I've graphed 2x sine of x. Kiddos, why is my window randomly 0 to 7? You can make your window what the interval says. It kind of helps out a bit. You might still have to play with the y values, but the x values, hey, they're ready to go. It says at x equals 4. So question, on my graph, why am I, quick shortcut, you can hit second trace and do value, or you can just hit trace and type in 4. Why am I at 4? Because that's what they said to do. So I can see over here, I'm going to do a quick sketch just for sake of having it in the notes when I put it online. When I see this graph, I see it doing something like this-ish. It doesn't need to be perfect. You do not need to show this on your work in the sense of on the AP, but for future reference, it might be helpful. So let's look at this. This is a graph of y equals f of x, yeah? This is y equals f of x. This isn't the derivative. This isn't the second derivative. This is the original function, and they're asking about the original function's behavior. What is, oh wait, you guys keep on reading the question. We're looking for what's true or what's false? We're looking for what's false. All of the following are true except f is decreasing. Well, there he is. Is he going down at that point? Check. So forget him. He's right. F is concave up. Is he concave up at that point? Yeah. Forget him. That's fine. F prime, nope, F double prime. F double prime is positive at that point. Wait, forever card. Have to read it. F double prime is positive. What do we know? F is concave up.
The top of that, please.
F is concave up. Is that true? Yes. Forget that one. F prime is decreasing. Wait. F prime is decreasing. That's in a forever card. Can anyone attach it? F prime is decreasing. When does that happen? When F double prime is negative. Wait, F double prime is negative. What does that mean about concavity? F is concave down. Does this work? No. But guys, that wording is in a forever card. What am I trying to get to? Forever card. Yeah. Some of you guys, your biggest weakness is just not knowing the forever card, which is why over spring break we're going to have another quoting assignment. Which, once again, is going to be bonus quotings available. And that's a good one because that goes straight into your test quiz. Bridget.
Which forever card is that again?
This is the concave up, concave down card. So the concavity test. The concavity test. So then last but not least, F prime is negative. Kiddos, why was that true? We know it's true, but why is it true? Slope down. Or you can think F is decreasing. We're attaching it, right? That's true. All right, number 3 is done. Let's go find number 5. He was another graphing calculator one, but actually we don't start there. Start by reading the question. The x-coordinate of the point where this guy has a tangent line parallel to. What do we know about parallel?
Same slope.
Same slope. But wait, who is this guy's slope? Who is that guy's slope? I don't know.
3.
Yeah, but just double check. Shouldn't you maybe get y by itself? So you would have negative y equals negative 3x plus 2. Then you would divide everything by negative and you get y equals. Okay, it is a positive 3x. I was just saying solve for y because sometimes that might change. So I know m of the tangent line needs to be or equal 3. What do I know about slopes of tangent lines? Derivatives. Oh! All we need to do is what? Get the derivative of the function. So the derivative of this upper function is 4x cubed. Slope of the tangent line is derivative. When you see that, set the derivative equal to 3 because that's what the slope needs to be. 2 ways of doing this on the calculator. Who can give me one?
Graph.
Graph what?
The derivative.
Graph the derivative.
And-
Graph 4x cubed.
And 3.
Yep. We can graph 4x cubed, 4x to the power of 3, minus 6x squared. And what Ryan is saying is we can graph one side of the equation. We can graph the other side of the equation. I'm going to go zoom standard just because I messed it all up. And we're just saying, when are they equal? And kiddos, in the graph, they are equal when they intersect. So we could go ahead and find the intersection. Second calc, find the intersect, number 5. Dun, dun, dun. Got it. To be honest, if you can see the intersection, this is the fastest way to solve an equation, is to find the intersection. If you can see it, if it's not on the window, you might be like, life stinks. If you can see it, intersection is the fastest way. If that didn't work, if the window didn't show it, and you're like, I really don't want to go looking for this thing, what's the other way you could find 1.746? What could you do, Katrina? Subtract the 3. And if I subtract the 3, I'm just going to say for this one equation, when I subtract the 3, when does it equal? What am I going to find? The 0. So I'm going to go ahead, and if the window is all funny and the intersection's way up here, whatever, the 0 will be down here in the axis. So I could do second trace. I could do 0. I could do a little bit before. I could do a little bit after. And I could find 1.746 both ways. I want to take time because one of the big purposes of using a graphing calculator, where they're going to require you to be able to use a graphing calculator, is something where you're solving equations using your graphing. So either way we do it, I'm going to do 1.746. If you guys didn't know how to use your graphing calculator, I would say something to the extent of something to the along the same lines as you can either use intersect with y1 equals y2, where one side equals the other, or you could use the 0 feature where you subtract whatever's on the other side and you're trying to find the 0. 2 different ways of solving. Do we understand how to use our graphing calculator for that? Cool. Done to love that. So then the other question, number 19. Oh, guys. The minutia. I'm going back to that video that I had you guys watch with AP reader, or the AP, it's much higher than AP. Are they making you do the calculus or understand the calculus in this problem? Are they making you do the calculus or understand the calculus?
Understand.
Because what did they give you? They didn't make you find the second derivative, and what are they asking for?
The relative max.
How?
Second
When you
derivative.
see something about the second derivative and a relative max, what forever card do you need to go back to?
Second derivative.
Relative extrema, second derivative test. Second derivative test for relative extrema. Someone, pop it off. What's that card say?
There's the unpip, and then you plug in the pips and endpoints.
No. Pips and endpoints would be absolute extrema of the second derivative. Absolute extrema of the first derivative. No one? Second derivative test, write it down. Second derivative test, relative extrema. You need to find critical numbers, you need to plug into F double prime. I'm just summarizing them. Some of you were saying if F double prime is greater than 0 and you were along the right track, F concave up, and it's going to be, or it could be a relative min. If F double prime is less than 0, concave down, if it's a critical number, it will be a relative max. This one says could be. Why did it say that? Because we cannot know whether or not they are critical numbers. You're not meant to integrate. Remember in the interview, they said if you're doing all this crazy math for one single question and it's just super hard and intense, if you try to integrate that, you're going down a rabbit hole. You're just going to waste time on a problem doing the wrong thing. They say could be. Could be. Well, I don't know. They gave me a second derivative. I guess let's test concavity. they give you a question, you have to work backwards? Kiddos, what's f double prime? Try A. What's f double prime is 0? 0 times a lot of stuff. Actually, ln of 0 does not exist. This doesn't even exist. Well, that's not going to help. There's no concavity. It can't be that one. What's f double prime of 1? 1 times 1 plus ln of 1? That's just 0 times 5 minus 1? That's going to be a positive number. Positive number means concave up. Question, can concave up give me a max? No, concave down does. Well, forget that. We don't want positives. Ugh. F double prime of 4. We have 4 times 4 plus ln of 4. Well, it's higher than 0, so that's fine. And then 5 minus 4, well, that's a positive. Hey, those are all positives. That's concave up too. Well, forget him. We're looking for someone who's going to make F double prime negative, aka F concave down. If you plug in 5, long story short, you're going to get 0. It's not him. F double prime of 6. Guess what sign you end up getting there? Negative attaches, concave down attaches to a possible relative extreme. 19 was tricky. You had to work backwards, and all they wanted you to do is find the one that has a concave down portion. That's the only one that even could be a relative max. Let's go to the FRQ. Great FRQ, typical FRQ. Remember I gave you guys that link. It's on the AP exam review. Lynn McMullen. Longtime calculus teacher turned into basically calculus expert and AP calculus expert. He has that page where he goes over a video of each of the typical types of problems. The graph of a derivative is one of those types. We have the graph of y equals f prime of x. Some of you say that you just get confused about looking at a graph, so let me help real fast. If you are given, I would do this in your colored pen, if you are given a graph of a derivative, you think about original values using area under. Using area under or integration. If you're given a graph of the derivative, you think about original, that's going backwards, that's integration, you think about area. If you're thinking about f prime, you're thinking about y values. Because it's y equals on this graph. AKA, you can think above, below for signs, right? Above, below for signs of the derivative. Above, below, and I'm going to say x-intercepts because aren't the x-intercepts the critical numbers? X-intercepts are the critical numbers, or the zeros. Yeah, I heard that. F double prime. Think about the slopes. F double prime. Think about the slopes. That's how we always think about a graph of F prime. So, why did I go over that? Well, I think you have like what, at least 3 problems on this above graph. Okay. They tell me that this graph has, let's see, a horizontal tangent line of 2, so they tell me that this truly is the max. Is linear, this truly is a line from negative 1.75 to 0.75. Closed interval, yada, yada, yada. Okay, so on letter A, when it says find the relative max, someone, shout it out. Where?
Negative 1 and 3.
Negative 1, 2, 3, or negative 1 and 3? Good. X equals negative 1 and 3. Why? We have critical numbers since we have x-intercepts at each of those points. And f prime, the above, below, goes from above to below, aka positive f prime to negative f prime, and then from above to below on both. Since, you could say relative max. At, since should no longer be capitalized, I know I'm just being picky now. Since, how did you guys justify? This is half the battle, half the points. The signs of
F prime.
of f prime. Since f prime of x changes, don't just say changes sign. Changes sign is good enough for a point of inflection for the second derivative. say changes from what to what? Positive to negative, right? Kiddos, the AP readers know the forever card. You just have to say that. You don't have to say F then changes from increasing to decreasing. You can. You don't have to. That's good enough. You don't have to say the first derivative test for relative extrema. No. Just give them the fact that makes it true. So then letter B, when it asks for from this graph, where are there any points of inflection? Points of inflection, sign of who changes? F double prime. And how do I think about F double prime in this graph? Where is the slopes? Where are the slopes going to change signs? AKA, where is F prime going to change directions?
0.75 and 2.
Points of, that was an R, was really a P in my stylus. Points of inflection. At 0.75 and 2. Since. Kiddos, even if you don't know how to find it, if you can state a forever card, you might get the justification point and you have no clue how to answer the problem. Point of inflection. Since F double prime of X changes sign. Changes signs. Maybe they made copies of that. Since F double prime changes signs. You don't even have to say, you could say since the slope of F prime, which is F double prime, changes signs. That's enough. Where is F decreasing connected to a forever card? F is decreasing when? Yeah, who is negative? F prime is negative. So, when F prime is less than 0, you can say that, or when F prime is negative. So, if you want to, you can start with the forever card. You can say, since F prime is less than 0, on, okay, what interval? Whenever they say interval, you need a from and a to.
Negative 1 to 1.
Yeah. Why negative 1 to 1? Wait, less than 0? Uh-oh. Hold on. F prime. Can we look at F prime by? Look at above. Oh, literally. Above, below. So wait. F prime is negative when F prime is below. If you need to, put little signs next to those. The above is when F prime is going to be positive, and the below is when F prime is going to be negative, right? The above is when F prime is going to be positive, the below is when F prime is going to be negative. So if I need F prime to be negative, I'm looking for below. So where is the graph below? Negative 1 to 1. Oh, I'm sorry, I was looking at negative 1.5. Struggle, you guys were totally right, good job. Anything else? 3 to 3.5. F is decreasing on those intervals. I just showed you another way of orienting your question. You could start with the forever card and then end with the answer. And if you guys notice, I'm stealing a whole lot of their wording because they're smart and they put it that way, so I can too. Is the function twice differentiable? What does that mean?
Can it be
Right again.
Can the second derivative be taken and exist everywhere? Second derivative, look up slopes. Are there any places where the slopes are going to be any?
Yes.
Derivative?
Sharp point.
Woo! 0.75. F double prime of 0.75 does not exist since F prime of X has a sharp point. You can put a no if you want. No. F double prime of 0.75 does not exist since F prime has a sharp
had a weird answer where it was like, because it is positive at the left and negative at the right.
They're just talking about the one-sided limits not agreeing. It's totally good for you guys to be like, no, sharp point. That's what a sharp point, that's why a sharp point doesn't exist. So they're just saying because the one-sided limits don't agree. You guys are good by saying a sharp point. Is that cool?
Yeah.
At that, that's value. It just hasn't updated yet. Hey, kiddos, we're done with this one, right? Okay, pass it up and let's get going in that next packet of fundamental theorems of calculus. As you pass up, open it up and remind yourselves of the two different variations for the fundamental theorem of calculus. It has something to do with capital F, the antiderivative, definite integrals, and derivatives of integrals.
Then you put our name on it.
Oh yeah,
I'll try this.
it's okay. I'll come back. I'll come to you.
Now the right is
You guys are passing up the next.
Everyday.
Okay, remind yourselves of fundamental theorems. Antiderivative, antiderivative, yeah. What about d dx of an integral from a to x or a to u? Okay, any more? Just pass them straight up.
Four. It's not cool as 7.
7 to like, it's not like a nice interval.
Why don't you ask, if you see her, ask Ada if she'll be around. Is she a 6th or 7th grade free? And if she's tutoring hours. But then if not, don't worry, Sarah, we'll get it done. I just figured that could be like your own personal the whole time. Alright. Fundamental theorems. We have some good time to get some good work done today. Some good questions answered. You guys reminding yourselves of fundamental theorem stuff? How many parts are there to the fundamental theorem of calculus? Focus, focus. Turn those groups.
2.
Two parts. Are you guys seeing any forever cards as you're reviewing?
Yeah.
That's why your office copied them off in the wrong order. I have the wrong one ready for today. You guys need to be talking in your groups if you've already gotten into problems. I'm sorry, I'm getting there. The office just did this in the wrong order, so.
Did 2, yeah, E. Cool. And then D. I'm stuck on a little bit.
And 3.
Yeah.
Yeah.
I was God today, so I remember the days of God. So I've always struggled whenever there's an integral with like an X in it. I think it freaks out.
Wait for one, you got.
What was A?
It should be like the negative. Switch the bags.
I think it's B. I feel good on B.
Yeah, that's what I was getting.
Four is C, right? Because the antiderivative of F will probably just be F by What graph are you using?
Just crack that.
The graph are you using?
Elephants up here.
No. So, when G36 is integral, that means all the area up to 3 is equal to 6, right? So it means G of 0.
Ryan, you gotta go with 3.
What? Yeah. So swap the bounds and make it negative.
Why? Just to make it negative, or when you make it negative, it switches the bounds, and you need the sign x to be on top.
Yeah. I don't know, but that's what we did and it works. Because whenever we see where the variable on top,
You want the variable on top because that's how you do the anti-gravity.
oh,
Alright guys, Google Drive is funny, but I went to
so
Hotmail one drive.
G, how do I do it? What am I doing? What's the integration? Does that change?
Because of F
What is how the integration does that change? Where
it
does
says take a derivative of an interval with variation of F.
G of A is equal to G of A plus the integral from A to B of F.
Yeah.
F of X dx. Okay, so.
Finally. Goodness gracious. Alright.
So G of A plus
0, 3.
Hey guys, did anyone see, no one brought this up, did anyone see, there was FTC part 1. Here we go, right? Oh, it's not up at all? Does anybody see integration as net change in your first page of the
5.
formulas?
I think it's 5. Oh wait, formulas.
In the very first important page of formulas,
Yes.
there's integration as net
Tomorrow.
change, there's FTC part 1, and there's FTC part 2. Sorry. Part 2 has to do with from A to G of X, or from A to X. Alright guys, I was trying to make it work and that's not working. Let's just do it the old fashioned way. So then AB exam review. And then foundation and oops.
2. I think it's 2.
Basically, 36 and I'm going to use
So if you guys notice, you do have FTC part 2 right here. You have part 1 right here.
it work.
You have a couple funny things that might show up, like if you're taking the integral of a derivative, FTC will let you just go back to the original. That's the antiderivative. You have the A to U, our other variation of FTC part 2, and then you have just a rearrangement. Integration is net change. You can solve for antiderivative of B by taking the initial plus the change in. Okay, so with that, where have you guys gotten stuck? How'd you do on number 1? FTC part 2 says derivative from A to X of anything is just f of X. So it's letter A.
See why?
FTC part 2 says if you're taking the derivative from A to X of f of t, the answer is just the integrand with X plugged in. That's it.
So you would just ignore A?
Yeah. As long as A is a number, you're allowed to just go straight with the formula. A can be 2, A can be -1, A can be a million, doesn't matter.
Okay.
For number 3, same thing except, it's rearranged. It's supposed to be from A to U, not U to A, so how do you work it?
Negative.
The formula says I need to flip the bounds. It needs to go from A to what they said was G of X. I said A to U because you guys are used to U being another function. So it's going to be negative and then just plug in sign, except, do you guys remember FTC part 2, if you go from A to U? It's going to be f of U times U prime. So what's our correct answer? B. We need the negative for flipping the bounds, I need sine being plugged into t, and I need times u prime, derivative of cosine. Sorry, derivative of sine is cosine. Number 5.
Oh, this was a good one.
Yeah.
This one's a rough one.
No, it's not. No, it's not. No, it's not.
It's a fun one.
It's fun, but it's just like,
One of those days, my smart board's gonna be done.
Yeah.
Don't ask me.
Call it a dump board. Get it? Sorry, that was really bad.
Kiddos.
Shut up.
All right, listen. This one's hard, but it's a great example. Sorry that school network and everything else is ridiculous. Kiddos, g is an antiderivative of f, so I can say g of 3 antiderivative of b minus antiderivative of a equals integral from a to b, 0 to 3. All I'm doing is plugging into fundamental thermocalculus. Antiderivative, if that's what they say, antiderivative of b minus antiderivative of a is equal from a to b. Now, when I think integration on a graph, what do I think? Area. 0 to 3. Oh, you're going to see a rectangle. I do. Or a trapezoid. Most people see the rectangle, see the triangle, and then see the triangle. What is the base of said rectangle? 1. What's the height?
3.
So I can say that area is equal to base, thank you very much, times height plus area is above.
Miss Joyner.
Oh, okay, yeah, go ahead and pick up.
Miss D's room, student speaking. Alright, no problem. Thank you. Bye. Aaron, go to the office with your books. For Mrs. Joyner.
Base is 1, height is 3. Why am I going to put minus?
It's below.
It's below. 1/2 because it's a triangle. What's base?
1.
Now, guys, if this was a long answer, you box that puppy and you leave it. Right? Because it's a base of 1 and a height of 1. Or you could say plus and then a negative 1. Either way, you're subtracting. You box that because some of you make it wrong when you try to simplify. But the sad thing is, in this one, we got to go for it. So we have 4 plus 3/2 minus 1/2. Oh, 1 times 3? Because I can't multiply, that's why. 3. I don't know. 3/2 minus 1/2 is 2/2. That's 1. And 3 plus 1 is? Ooh, look, they allowed for that mistake of adding instead. I don't know. Tricky.
No, Miss Diaz, what's our answer? We didn't finish. We're looking for G of 0, not the area.
I'm too busy about my iPad that's not working. Okay. This
Let's just take my phone out.
equals 4. And that equals G of 3. Good catch, guys. Good job. And who is G of 3? So 4 equals 6 minus who? Some of you can jump to 2, and some of you need to solve by adding G of 0 and subtracting. Yeah. So we got it. Questions? What did I use? What else did I use? An integral can be approximated by, and in this case it was geometric, by area. Good. I have to go ahead and delete all this, so sorry. I'll try to make a nice pretty copy and upload period 6's. Ooh, number 7.
Yeah, I know.
Ah, it's not an A.
Darn.
Except, doesn't a property of integrals say I can split this up from A to B. And then from that B to C. Guys, you could have picked any random number. It doesn't even matter. You can just call it A. From x to a and a to x squared. There's a property of integrals from way back when. You can split it up. Pause. You can't take a derivative quite yet. What else would you have to do?
Swap the x with 0, make it x.
Swap the 0 with the x. Now do I have a legal expression to derive?
Yes, ma'am.
Alright, get out of here, guys. Work on those odds tonight. I will save, listen, I will save period 6's notes with the nice pretty examples done online tonight in your notes folder for late foundation review. Bye. I'm gonna finish writing it and solving it for the sake of the video.
Huh?
Jason.
You see it?
So this is that whole plugging in the xy thing. For this one, when I plug in the u, I need u prime.
Well, how come you don't take the derivative of tangent?
Because I'm deriving. So this is FTC. When you derive an integral, the derivative of a to x of f of t is just f of x. Think derivative and integrals cross out like square roots of squares.
Ah.
Is that like your power juice for today? Oh, no one did. Because no one reminded me in class yesterday. So you guys are getting it back today.